totally quiet, totally focused, because I won't do it. I won't be able to do it in less than 7 minutes without that. So you already know a lot of this. You already know how to graph y is less than 2/3 x plus 1, right? So I go up 1, I do my y-intercept, which is up 1, put a dot, and then I rise 2, 1, 2, and run 3, 1, 2, 3, and so I put my dot here, right? Thank you, sir. Appreciate it. Right?
Wait, Gary, do we need to write this down because we already know?
Not if you know it, that's fine. Just watch for a second. So, because you do know this. Now the question is it a solid line or a dashed line?
It's a dash.
It's a dash. It would be a solid if I had put a line underneath it. That would tell you it's solid. But without that line, it's a dash. So I do my dashed line. And as long as this is written in slope-intercept, y equals, as long as this is for you to listen to. As long as this is written in y equals mx plus b, slope-intercept, y equals mx plus b, even though that's a less than sign. That's okay, it's still in the same format. Y sort of something is mx plus b, right? Y is less than mx plus b, that's fine. As long as it's in that format. If it says y is less than the line, where is y less than the line? Y is less than the line here. Don't you agree with me? Isn't y less? I mean, all these y's are less than this one. So it's going to go down. So it's going to be very logical and intuitive how to graph them when they're in y equals mx plus b, right? They're not as intuitive when they're in standard form. Before I show the standard form, before I do the standard form, sorry?
Why can't you just convert it to y equals mx?
You can, totally. You can. That's one way to do it.
We should do a problem.
What if I, oops, sorry.
We're like out of
Would have
time.
probably been easier to just, what if I said this, graph this, y is greater than -6.
Well, then don't you just draw that line at 6 and then go
Yeah, I go down -6, 1, 2, 3, 4, 5, 6. There's -6. I put a dot. And notice that there's no x. So y doesn't care wherever you are on x. Y is -6.
not care?
So even if I was over here, it doesn't care what x is. Y is still -6. It doesn't care over here what x is.
Doesn't care about
So
your
it's
feelings.
going to be a straight dashed line,
Oh, it's
right?
dash.
And it's going to be greater than, right? It's going to be greater than. So I'm going to be, doing this, whatever, shading up. What if I had said, I'll use a different color. What if I said this, x is less than 4. How would I do that? X is less than 4. Yeah, x is less than 4. I go 1, 2, 3, 4, put a dot.
Oh my god.
X is less than 4. Even up here, no matter what y is, x is still 4, 4. So it's going to be a dashed line vertical, and it's going to go this way, right? Got to be less than that.
Simple. Is it always
Right?
going to be y? Gary, where's
So
the problem?
y, if it doesn't have any x's, it's always going to be a horizontal line. If it's this y, it's going to be a horizontal line, which is weird. Because you think of the y line as vertical, right?
Gary.
Because the y-axis is. But in this case, the y line will always be horizontal. The x line will always be vertical. Okay? Is that clear?
Really, your problem.
Wait, I have a question, Gary.
Yes.
Where's the problem that will confuse you so badly that you fail your entire homework?
Okay, I'm about to do that right now.
Okay, thanks, Gary.
And it's really quite simple. It's really quite simple. It's just you have to understand the process. If I give you something that is in slope-intercept, meaning 2x plus 3y equals 12. Not equals, sorry.
So you minus
Is less than 12.
Oh, Gary, I wrote it in pens.
Wait,
Well,
so
just
then,
make it.
x is,
You do the
x
minus
is less
you do when you graph these is you pretend, this is important, you pretend, I only have 1 minute, right? You pretend this is an equal sign for a second while you figure out your points, right, on your graph. So remember, we're going to use x and y intercepts. When x is 0, y would be 3y equals 12 divided by 3, y would be 4, right? So I go up to 4, 1, 2, 3, 4, and I put a dot. Then I say to find my x-intercept, I make y equal to 0. That gives me 2x equals 12. I'm changing that to an equals while I figure it out. X equals 6. So I go 1, 2, 3, 4, 5, 6, and I put a dot. Now, is it going to be a solid or dashed line? A dashed line. So I have a dashed line. All right, so that was pretty easy, right? All I did was found my points by pretending that was an equal sign, by making x 0 and then making y 0. That was really easy. You know how to graph those. The question is, which side of the line do you shade? And in this case, just because it says less than does not mean you shade down. And if it said greater than does not mean you shade up.
I noticed that on the first one we did, it said less than, but we shaded up.
Oh, we did?
Yeah, we shied up.
Good job, Gary.
It was this one, and then we shaded up.
Oh, good.
Good job,
I
Gary.
didn't shade up.
It said minus.
Did it say?
It said less than, and then we shaded up.
And then
Or greater than, less than.
I thought it said greater than -6.
Well, we had two of them, and then they were both different, and
Okay.
they were,
Well,
and then we shaded up on both.
Sorry, if it says greater than, in that case, it would have been up. And if it said, or,
Yeah,
to
the
the
second
right.
one was less than, but we
Okay.
shaded up.
I might have screwed up, sorry. So, what you do to find out is you actually choose a point. Any point on the graph works. And every point has an x and y, right? Remember how we did this with systems of equations? We had our answer and we plugged it back into the original. If x was 2 and y was 3, we plugged that into the original equation to see if you get a true answer, right? Remember that? So, we're going to do that, but we're going to choose the easiest point on the graph, which is right here, 0, 0. Almost always choose 0, 0. The only time you don't choose 0, 0 is when the line goes right through 0, 0. Right? Then you have to choose a different point. But we're just going to deal with this for now. You don't have to worry about that other issue yet. So, look, that's my x is 0 and my y is 0. So I come up here and look at that. Both x's and y's are on the left side, which means it's 0. 0 plus 0, right? 2 times 0 plus 3 times 0 is 0. So look at that. By using 0, 0, immediately on my left side, I have 0 is less than 12. Is that true or false?
Let's go.
That's true. Therefore, this point right here is a solution to that inequality. Does that make sense? Does that make sense? So you shade towards that, yeah. Now what if it was false?
What do you mean shade down?
Then you would shade up.
What do you,
That's
wait,
shading down.
Because, see, 0, we just proved that 0, 0 is true,
yeah.
right? Because 0 plus
So
0
then
is
you have
0.
it less
0 is less than 12. Therefore, this is a solution. Therefore, everything on that side of this line is a solution.
Oh.
That's the way inequalities work. If one thing on a particular side of the line is true, everything on that side of the line is true. But if any one point is not true on that side of the line, nothing is true on that side of the line. You have to jump to the other side of the line and shade there. Does that make sense? Yeah. Okay.
Why did we talk about this tomorrow?
We'll talk about it tomorrow, but this is the homework tonight to practice, okay? This was too short of a lecture. I apologize.